Hi, welcome to the Ben and Chris show. I'm Chris.
I'm Ben.
And today we're going to talk to you all about Python programming. So it's been a little while since we did one of these broadcasts, Ben. Before Christmas, before lockdown 3.0. Usually in iterative development, things get better, not worse, right? So really feeling for everyone out there at the moment who is in lockdown. But hey, hopefully you're taking this time to learn a bit of Python. So it feels like a long time ago since our last episode, where we were talking all about loops, and we ended up kind of going a little bit further than we expected in that episode, and we went from loops to actually bringing everything together that we worked on to write our first piece of software, which was essentially a very basic kind of financial calculator, financial planner. But if we bring in Ben's screen, as you can see scrolling down, we've actually left in weak force code there. And if you scroll down a bit,
yep,
it's a long old string of code. It's not the most readable in the world, as lovely as Ben's code is. It's fairly unruly, right, Ben?
Yeah, I mean, as you can see, I've just uncommented now, so it probably, even with things like syntax highlighting, you can still see that this is still a bit confusing, and it's something we talked about in the last episode. Is when we want to do stuff like this, we want to use loops, and now we've got loops inside ifs, and we've got this all of this inside a while loop. You can start to see that this becomes a bit unreadable. So what is the solution to that? Well, there's a bunch of solutions. I could write more terse code. I could maybe reduce the spaces, call things similar names, and so forth. But one of the main ways of getting around this is to actually just bundle up blocks of code into separate procedures, functions, and stuff like that. And that's what we're going to talk about.
Do you know the way I like to think of this, Ben? I love a good analogy, right?
Yeah.
I can remember when I was when I did DT, when I did engineering at high school and sixth form. And I can remember one of our projects was we built a toolbox and we built a hammer. Right, we built these tools. We did a bit of forging and we put these tools together. But once I'd built them, every time I needed to knock in a nail, I didn't need to build a new hammer. I'd already built that hammer. So now I've gone through and I've built my hammer. Whenever I have a nail, I just reach for my hammer out of my toolbox and I hit that nail. And that's how I like to think of functions. When you're writing a function, it's like building that hammer. You're building a tool for a very specific purpose, and we'll show what some of those purposes can be in a second. It's a tool for a very specific purpose, but whenever we have that purpose, we can use that hammer. Every time we see a nail, we can use that particular tool. And if I haven't got a nail, if I've got a screw, well, I need to build a screwdriver. And I'll go away and I'll build a screwdriver. Once I've built that screwdriver, I can use that on any screw that I see.
Yeah, that's a pretty good analogy, actually. I was actually before we came into this, I was trying to think of a good analogy, but that's a really good one.
Love a good analogy.
Yeah, but that's the idea, right? Is every time you go to hammer a nail into a piece of wood, you don't have to build the hammer each time you hammer in. That'd be silly, right? I mean, you'd be stuck there for I don't know, I see months, years.
B&Q would go out of business, basically.
Yeah, but it's the idea behind it is that we can reuse certain things. We can reuse a hammer to do things like hammering in nails. You buy a measuring tape, and you can use that measuring tape for a bunch of different things. You don't buy a new measuring tape every time you measure a piece of wood or something. And this is one of the very handy things about functions or procedures, is that we can use them to reuse bits of code. So I suppose
let's actually just take that as an example, Ben. Let's write a function called hammer.
Okay, hammer. Right.
So let's talk through what a function looks like.
Okay. So usually when you see a function, when you're defining your own function or procedure. There is a slight difference between a procedure and a function, but for the case of this lesson, we're mostly just going to kind of interchange between the two. So a procedure doesn't return anything, a function does, but that'll make much more sense when we actually get into the nitty-gritty of how we make these. But every time we make a procedure or a function or subroutine, whatever you want to call it, we have to use this def keyword, and this def is short for define. So this means define a method called hammer, right? And this is what identifies the function. So this function has a name, like a variable has a name, called hammer. And the brackets, we'll get onto what they are later on. For now, just imagine that you need that as well. You need those brackets to say this is a function, because maybe if it didn't have that, it might think maybe it's a variable or something. But this is saying this is a hammer. You can see it changes color. And that's always a good sign. And you have to have this colon.
So our hammer function will say, let's just make it print some statements. So C nail,
Like that,
a new print line, bang nail, hit nail,
nail, yeah.
And another line, wood nailed.
Wood nailed. Okay, yeah.
And another line that says success with a little exclamation mark because we're happy about it.
Yeah, okay. Cool. Right. So yeah, this function, right, called hammer. So we have to use def, but this line basically translates as define a function called hammer. And this doesn't have to be called hammer. It could be called whatever you like, but for the purpose of this, we're just calling it hammer. The brackets and the colon, we just kind of, for now, we just have to have those.
Then? Just because I've got a good idea down the line. Let's duplicate that function.
Yeah. And
let's call it screwdriver.
Yeah.
And then just change the nail to screw. And while you're doing that, I'll just talk through why I've done this. So the good thing about functions is we're packaging up modular reusable code. So again, like that hammer, once we have that hammer, we don't need to build it or buy another one. We've got a hammer, we reuse it each time. So we know how to write our if statements and how to write the beginnings of a piece of code. So let's do that. Let's have an input field.
For this, yeah?
Yeah.
Yeah, okay.
Where we're going to go screw or nail. Type 1 for nail, type 2 for screw.
1 for nail, 2 for screw. Yeah.
And then we're going to have an if statement.
Yep.
Which is going to say if 1, use the hammer function.
Mm-hmm.
If 2,
yes. If choice 2.
Use screwdriver. So what this piece of code is doing, in a relatively non-elegant way, we're asking the user, what is your challenge right now? What this is our toolbox. We have 2 tools in our toolbox. We've got a hammer and we've got a screwdriver. And we say, what do you want to use? And it's going, you type in, you say, well, I need, it's a nail. Or it's a screwdriver. Now, I don't actually need. You notice how we're not saying what function do you want to use. The code, we're getting the user to say what problem do you want to solve, and this is generally quite a good way to write interfaces. Anyway, we're asking what problem do you want to solve, and those if statements are using the right function for what we've just typed in. So let's just try running that.
Yeah. So if we run this, it says screw or nail. 1 for nail, 2 for screw. So say we put, I don't know, 1, it's going to say C nail, hit nail, wood nail, success. So this has called this hammer function, and we'll get onto what this syntax means. If this stuff's a bit confusing, we're going to go over it in a second, but let's rerun this. If we put 2, you can see it says C screw, hit screw. I mean, I'm not sure if hit screw is the right word, but hit screw, wood screwed, right? But that's the idea, is that we've called either one of these depending on a choice, which is what we covered I think it was a week or 2 weeks ago in selection.
I was just looking. I usually have a hammer and a screwdriver in my office, but not today.
Yeah. But yeah, what this means is, so when Python sees hammer like this, if it saw hammer without the brackets, it would assume this thing is a variable, right? But if you put 2 brackets over there, what is happening is it's saying go off to this, go find a function called hammer. And as you can see, as I highlight this, you can see it's highlighting up here because it knows this thing is a function, right? These 2 brackets here mean go find the function called hammer, which is this one here, and then start running the code here. So you can kind of think of this functionally. I mean, it's not exactly the same, but you can kind of think of this as Python goes to this line and goes, oh, I need to do the hammer. It goes off and it finds this function. It takes this code and just kind of pastes it in there for you and runs it. That's one way of thinking about it. It's not exactly the same, but that's the idea, is that by calling this, we're saying hammer, and these 2 brackets mean it's a function. We're calling a function. That's what when we say go off to that function and start running the code which that function has, that's calling or invoking a function. So here, hammer brackets, it's going to go off to this function called hammer here, because we've defined this function. It's define a function called hammer, right? The brackets, don't worry to do too much about that. We're going to come into what that means later. And then it's going to run this code. And once it's finished this code, it's going to come back to where it was. And this is why it's so useful, because if we wanted to print out these 4 lines anywhere, we wouldn't have to copy and paste it over and over again, you know?
Just like the nail example, right?
Yeah.
If, when think you've got a barn to put up, and you have 100 nails. Imagine if every single nail you had to go away and build a hammer every single time. No, all we're going to do is write nail identified, call the hammer function, do the hammering task, move on. What's the next thing? Another nail, call the hammer function. And that's essentially what we're doing with our code. We're saying this is something that we want to... Sometimes we break stuff out into functions just to clean things up. Just to kind of tidy up our code and abstract out things that sit neatly together as a block. And sometimes that might be things that we want to do in different contexts. So again, we talk about that barn. I might not just want to use my hammer when I'm putting nails into that barn. I might also want to put a nail into a wall to hang a picture. The function is exactly the same, but the application is different. We quite often put, say, mathematical code. So we talk about data analysis, and that's hopefully where this series is going to go in a few episodes. There are a lot of basic mathematical functions that we might want to repeat 1,000-2,000 times. If we put that into a function, we don't have to write it out every single time, but we might apply it in various different contexts.
Yeah, and this is where functions start to come quite useful. I imagine, if you've never come across functions and you're just seeing this and you're understanding, oh, right, okay, I get what a function is. And I kind of see why it might be used, if you have long blocks of text, it might be useful. You can reuse these blocks of code, but you might think, well, what's the real point? What's the power behind this? And it becomes really useful, as Chris said, when you start thinking about things like mathematical functions. Mathematical functions, things like squaring a number, producing a factorial. If you want the, nth number of the Fibonacci sequence, having a function to do that for you without having to rewrite that code over and over again every time you want to do it can be really useful. You've come across functions and procedures and all kinds before. Things like this function, input, that's a function. Int, that's a function. Print is itself a function. And there's other things which we're going to talk about. These are just some very basic procedures. Though we're bundling up a bunch of code like this, these 4 lines of code here. We're giving it a name. We're saying this is hammer. And then whenever we call it, whenever we have these 2 brackets here, we're saying run that block of code and then return back to where you were, which is really useful.
So let's create a function that returns a random number.
Okay. So so for this, I'm going to have to write this. Now, don't worry about this so much. I'll show you why I have to use this. Right. The way to produce a random number in Python is you have to tell Python to go off and find some code outside of this program. And this, what this doing is it's saying import all the stuff from the random library. If we just
Which you can think of a whole bunch of code, a whole bunch of functions that somebody else has written for you.
Yeah, exactly. And you know, funnily enough, we're talking about functions and stuff. This is the utility behind them, right? Is I could write a bunch of functions for doing a certain things, and then I could ship it off to somebody who needs those, right? If I'm a mathematician and I've made some functions on factorials and all kinds, by bundling up that code and putting them in functions, they're reusable not just to me but other programmers. And this is where it becomes really interesting, because that's what, as Chris said, that's exactly what this is. You know, somebody years ago has made this this collection of code called the random module, and has made it available for people to use. But
it would be entirely possible to write our own block of code that generate. I mean, it would be a big block of code, but we could write some code that would generate a random number.
Yeah.
I mean, we do things like this, you know, where we but ultimately behind that, like I say, behind that import is just a whole bunch of code that somebody else has written. You know, it's, and like I say, Ben, this is where it becomes modular and useful and stuff that we can import and share around. So yeah, let's create this function that just, all it does is, I'll tell you what, let's make it just to give it a bit of girth. Let's make it multiply two random numbers together.
Okay, cool. So I don't know what to call it, random number.
I'll tell you what, no, let's get it to normalize between 0 and 10, because that's sometimes quite useful.
So just call it random number or something.
Yeah.
And then what we're going to do is we're going to use so the way you create a random number in Python is to use random.randint, and you put in between, say, 1 and 10 or 0 and 10. And I'll just show you this before we actually put it in a function, so you know exactly what this is doing. So let's put this here. Let's call this num. And if I print num after all this, I'll just comment all this out just for now. All this program is it finds a random number between 0 and 10, and then it shows it. So if I run this, I get 9. Here I got 5, 7, 9, 8, and so forth. But that's how you generate a random number between 0 and 10 in Python. But let's put this in a function, right? So if I have a function here called random number, and we're defining it because that's what this def thing is, we could do the same thing. We could copy this, right? And we could put it in this function, and we could return, right? Now, you haven't seen this before, but we can return num. Okay.
So this would be like, I always think of return as the function being containing a helpful little elf. and when we call the function, it's almost like shouting to that helpful little elf, "Hey elf, do this thing for me." And the elf runs off, and you know, in his patterned socks, and he does the task. Or her, you know, there's a variety of elves, and they run back and say, "Here, I'm returning this thing that you've just asked me to do." So that's the worst analogy in the world. Like, you know what? Genuinely, I mean, not a joke. When I was first learning to code, that's how I thought of it. There was just this little happy little code elf that was just doing things in the background for me. So what we can now do is we can now put the function in a print.
Yeah, so let's do print random number, right? Now, if we run this, you'll see we get the same thing, right? We get 3, we get 8, we get 1. And the reason this is different from something like this this hammer function is, well, if you look at this function and you look at this function, the biggest difference is this return thing. Return can be tricky to get your head around, but like Chris said, right, it is, you can imagine it kind of like
so it's returning something to you.
Yeah, there's communication there, right? Here, this hammer function. You say do this, and it just goes off and it does it, and it doesn't report anything back. Whereas here, what this does is it will generate a random number and then it will return that back to where it was. So you can kind of think of this as well. Okay, let's extract this out a bit.
Call and response, right?
Yeah. So let's call this. This is a similar thing, right? So this is exactly the same thing. We've just extracted it into a variable. So what happens when Python sees this random number is it does the same thing as hammer, right? It will go off and it will start executing this code. It will find a random number between 0 and 10. It will, this will be replaced with something like, I don't know, 5. What this return does is it replaces this with the random number. So maybe it'll be 5, maybe it'll be 7, maybe it'll be 10, whatever. That's what return does, is it's returning that number back to you.
So I think if I was in the position of a new programmer, I would be going at this point. But why? You've just demonstrated here, Ben, that actually you could just write that code in. What's the benefit? And I think the reason I would like this random number one is thinking of coin flips. And if you've ever kind of bet on something, maybe you say, well, okay, let's do the best of 3 coin flips. Right. So in our random number, in fact, let's just comment that out and create a new function called coin flip.
Okay.
And this time we're going to pass in a variable, an integer called number of flips. Now, in there, we're going to have a loop for the number of flips. And actually, we're going to have a variable just outside of that loop called wins. Okay. So in there, we're going to generate a random number between 1 and 0.
One and 0 like that.
Yeah. And if the number is 1, then we're going to iterate. So we're going to add 1 to the wins. And we're going to return wins. So now we have a function that actually we've jumped forward quite significantly here, but I think this is a useful step. We talked earlier about what those brackets were for, and that's actually what we call passing in an argument. So that is something that we're sending to the function to say, I want you to do something with this thing I'm giving you. In this time, again, now our little code elf just has a coin, and it's waiting for us to ask them something. And we're saying, right, elf, I'm going to ask you to flip that coin a number of times, and I want you to tell me how many times that we get heads. Okay, now if we call that function, so if we do a print statement, and this time we're going to get it to flip 4 times. And let's do another print statement. Another time, calling that function again, and this time we're going to get it to do it 400 times. And we'll do another one. And this time it's going to flip 4,000 times.
Okay.
And actually, that's really bothering me. I think it should do 40 times between 4 and 400 as well. It's just upsetting me that there's like a lack of symmetry.
Yeah. Okay. There we go.
So, what we're doing now is this relatively complicated. Well, it's not really complicated. I mean, we've done variables before. We did that in episode 2, I believe. Yeah, episode 2. We've done loops. So we did that episode 4. And now we've done functions. And now we're passing. We've gone from this very simple hammer function, just banging this nail, to something where we actually have some variable function there. We're asking it to do something slightly different. based on what we're calling. Now, if we didn't have that function, every single time that we did this print statement, we would have to pull out that full code. We'd have to type that out in its entirety. Let's run this.
Okay.
I love how fast that is.
Yeah.
So think again. That's it's the joy of computers, right? We've done that 4,000 times, and it was, or 4,444 times.
Yeah.
And yeah, so the first one we won 3 of the. Is that 3 or is that 2?
I think it's a 2. Yeah, I can zoom in a bit if that helps.
Yeah, that's better. Okay, so the first 2 we've had even Stevens, right? Okay, so that's showing random numbers basically working, right? So it should there should be a fair distribution. So 220, 205, and 1,951. So we've got even, win, and a lose. Okay, brilliant. So now we have actually a relatively useful piece of code. We could package that up. We could Ben could share that with me, and when I'm creating my gambling elves video game, I can use that code. It's abstracted, it's useful, and whenever we want to flip a coin, we can just call that function to do it.
Yeah, it's this is the utility. Like one of the biggest thing that's probably we've left forward here is this idea of passing things into functions. So we've looked at 3 kinds of functions, right? So we've looked at something like hammer, which is technically called a procedure, where it just goes off and it just runs some code.
Although you're the only person I ever know who insists on that.
Yeah.
I always go to say it's a function. But I suppose it's so rare that we actually write procedures, isn't it?
Yeah, I mean, I often, the reason I use functions a lot is because you can communicate back. You don't see procedures that much unless it's printing out say instructions for your bit of software, or a header or something like that, something where you need to just reuse. You can't be bothered typing out these 4 lines of code every time you need to do it.
Actually, the only time I ever really see procedures is actually it's often in code, where you'll do stuff like you will have an automatic header generator, and every single time you're generating roughly the same header in the comments, so you write a procedure to do that. Yeah,
exactly. And that they have their utility, right? They don't communicate back. Then what we've done is we've looked at something like this one here, and I'll just then comment this, where there's no arguments being passed in, but what we're doing is we're communicating back. We're generating a random number, and we're saying, okay, return that random number back to us. And
it's quite often that we actually want to do that. So, for example, again, imagine this is a robot, and we just want we just want it to do a thing repeatedly. Maybe we just want it to move forwards until something, until its sensor picks up something. So sometimes we just wrap up a function in that way, and that can actually just be really handy. So one of the best examples we use of this is we use date in code quite a lot. And we don't really want to pass in an argument to date, because the date is the date. The time is the time, right? We're not going to say, give me the time plus 1, or give me 5 multiples of time. You just want time, and you just want to say, I want time, and it gives you time.
Yeah. And you do find ones like this, but the most common one, the most common kind of function you come across is something like this, where you pass something into the function, it does something, and then gives you a result back. So return here, it's when I started programming anyway, this is the one thing that really confused me, right? I was always thinking, but I don't know what return is, and it can be quite confusing. I think it's one of these things where you just sort of have to practice it and try it out. Try and write your own functions with return and see what it does. But the best way I can describe it is like we talked about before. It's almost like communication. We're saying return that value back to us. So we're doing something, and we're saying we want an answer. Whenever you can whenever your function has an answer, it's most likely going to return it, right? So here we just generate a random number, but we're going to want that back. So if we do something like a equals random number, the way I like to think of this is in my head, I imagine it like replacing. So say we had a function. I'll write a very useless function. So I'll call this useless function. And all this does is it just returns the number 5, right? Now, this is a very useless function. It does nothing but return the value 5. We could just write 5. But the idea is that if I call this useless function, it's going to go off, it's going to run this code, and it's going to return 5. Now, what that 5 is going to do is it essentially replaces this with that. And that's how I got used to what return does. It's almost like replacing the value of something, much like a variable. If you had something like a equals 5 and you do b equals a plus 1, you can imagine this 5 replacing this a. You can kind of think of it the same here with a useless function, right? We could do 50 plus 3 or something, right? And this will give us 53. But what's going to happen is it's going to replace this thing with that. And that's what return kind of does. That's the way I like to think of it anyway. Here we have random function, random number. And what this does is it generates a random number. And then that random number, whatever it is, it could be 5, it could be 7, it could be 10, it could be 1, 2, 3, whatever. This is going to replace this. Replace this with whatever that is, whether it's 5, whether it's 3, whether it's 1, and so forth. So hopefully that makes a bit more sense. And going along with the whole replace thing, this is where arguments, one of the things we left ahead with was this. We didn't talk about what these brackets are, right? But this is the reason these brackets exist is the idea of passing parameters. They're either called parameters or arguments. But it's the idea of passing something into a function. The function does something with that, and then we get an answer back. And that is incredibly useful. That is incredibly useful for a bunch of reasons. In this case, we're saying the number of flips. And again, you can kind of think of this as, again, replacing, right? So if you saw this line here, coin flip brackets 4, this number here, 4, is going to replace this number of flips here, this variable. And this is what's going to happen, is it's going to run 4 times, right? And, next time we call it, it's going to be 40. It's just going to replace it with 40. So that's a really useful thing.
Just for, and again, this is one of the things that I think is really useful. We talked about loops last time. Ben, just on that 4,000, change that to 40,000.
Okay. Yeah.
And change the others, change 400 to 4,000, 40 to 400, and 4 to 40. Yeah. Oh gosh, you're gonna have to put another 4 at the top as well. Sorry, it just upset me.
Yeah.
So again, this is we talked about loops last time and the speed and why this stuff is useful. This is doing a lot of computation now. And it's interesting whether the browser will be able to cope with it, right? But
well, we'll see. If I run this, let's see what happens. Yeah, just
wow. Can you just imagine doing that 40,000 times? That is. For anybody who's worked with computers for a while, that just. I think you lose the magic of how cool that is, right? The fact that this has gone away and it's done something, and I think the amount of code there, it's doing some relatively complicated stuff. It's saying generate a random number between 1 and 2, evaluate that random number. If it's a 1, do this. If it's nothing, do nothing, and then return that number. And it's doing that in that kind of speed. The magic of that never escapes me, of how cool that is, and how long it would take. Again, think of the elves. If I had 40,000 coin flipping elves, or just one, right? One, think of the amount of labor cost of hiring 40,000 elves to flip a coin one time, or the amount of how how scorched and worn out that poor one elf's finger is after he's flipped 40,000 times. And the computer is like, bang, and it's done. And again, and I must stress, I'm an associate professor of computer science, right? And we do this kind of stuff all the time, but the magic of that never escapes me. I still just think that is fantastic. Anyway, that was a slight deviation there. But, and again, this is all running through a browser. This is doing really. So again, think of this for your data analysis projects, your things that you're doing. The amount of calculations that you can do with code, boom, done, and that can be so powerful. And this is Anyway, I'll start my little rant. You reckon it's time? Should we start looking at last week's code?
Yeah,
and seeing how we can start abstracting some of that into functions.
Yeah, I think one last thing I want to mention is so the cool thing about parameters is you don't just have to have one either. So I'll just show you a basic example, right? Say we had a function called square, right? And we put in num, and what this is going to do is it's going to return num to the power of 2, right? If we print out square, I don't know, 5, right? This is going to give us well, it's going to give us, I think it's, yeah. If I stop that and I run it, I think running 40,000 times is I've lost the thing. Yeah. But if I run that, yeah, you see it says 25. Now I put in 5 here, and it's going to replace this num with 5 and this one with 5, and we're going to get the result of this, which is 25, and then this is going to get replaced with 25. Brilliant. So that's just one parameter because we're just saying square a number. But another thing we can do is we can have more than one parameter. So let's make a function called add. And add takes 2 things, right? We can't add one number to nothing. That doesn't make any sense. There's always something on the left-hand side and something on the right-hand side. Now, what we can do is we can call this maybe, A and B. And what we do is we just return A plus B. So say we have add 5 and 7. What's going to happen is it's going to give us 12, right? So what's going to happen here is 5 is going to replace A, like this, and 7 is going to replace B, just like this. This whole thing is going to replace this with 5 plus 7, which is 12. But that's the idea. We can have as many arguments as we want in here. We can have C. We can have something else, yeah. And the way we do it is by putting commas between them. So say if I have A, B, C, D, if I run this now, it's gonna throw us an error. It's gonna say has missing 2 required positional arguments C and D, and that's because it expects you to give 4 numbers. So just be aware of that. We've got 4 arguments here, A, B, C, and D. And it expects us to give 4 arguments here. Now, if I run this, it's going to give us something back. But that's the idea. Is we can have 1 parameter, we can have 2, we can have 3, and so forth.
And they don't always need to be of the same type either.
Yeah,
that's quite often they're not.
Yeah, so sometimes like one of them. That's a good point, actually. Something like add. I don't know. Maybe something like.
Actually, let's have a loop. So you've seen those matrix signs in Windows. Coca-Cola available here, and it just loops round on a matrix sign. Or we could create that in code. So we could have a function where it takes a number of loops and text to loop.
Text to loop, and I'll call this, I don't know, matrix.
Yeah, why not? And what it's going to do is it's literally going to create a loop. And the range is going to be the number of loops. And it's just going to print the text to loop.
Loop. Yeah. So yeah, let's call this.
And actually, it's really useful. Actually, now we've still got 2 parameters there. We've still got 2 things, but notice how you've got the red line under the code. Ben, explain why that red line's there.
Yeah. So well, the red line right now is because it doesn't know what add is, because I've changed this to matrix sign. If I change this, if I change if I change this to matrix sign, the thing is if I print this, right, you will get this none out, and the reason it says none, now this is an interesting one, because it really depends. Python allows you to do this, right? If a function doesn't have a return type, it doesn't return anything. Just like this one, it goes off, it just prints some stuff, and that's it. If it doesn't return anything, it lets you do that, because what we're trying to say is, this is saying print the value that this thing is returning, but obviously this doesn't have a return, so it prints none, because it's like, well, there's nothing, so none. Now this is okay in Python, but when you start looking at other programming languages, this would be a big red flag. You'd have.
I'd forgotten about that.
Yeah. No, I've made that mistake myself as well. I've gone, that's strange. It's a very weird thing, and I'm not sure exactly why they allow it. But in other programming languages, this is a very big thing. If this thing didn't return anything, you couldn't do this. But that's other programming languages.
Why would have void? But,
yeah.
But we'll talk about that. Right, let's go back to last week's code. Let's go back to our calculator and remind ourselves what that does. So we'll comment all this out.
Yep. This stuff here.
And it's worth saying, actually, we've got a bit of I don't know if it's exciting news, but it's news. We now have a website, the Ben and Chris website. So what we've been doing, and I'm just going to stick that up on a fancy banner because I can do that, I think. So no, that's not what I wanted. There we are. Edit that. Add this. Save. There we go, a banner. So you've got this website on the University of Lincoln page, lincoln.ac.uk/home/socks. So socks is the School of Computer Science, where me and Ben live. / the Ben, which actually not far from the truth at times. / the Ben and Chris Show. So on there we have all the old episodes. They're also available on YouTube, but they're I would say they're better archived on here. We've also got a whole bunch of worksheets. So if you want to remind yourself about any of this stuff, if you want to go back through it, just need some sort of memory. The worksheets are really, really useful. So last week's code.
Yeah. So I guess I'll just run this. So I've uncommented this, and as you can see, it's week 4's code. Now, if you've forgotten what this does, I'll just run it to show you, and hopefully I'll just zoom in actually so you can actually see that. So ignore this. This is just something from last time. What it does is it says press 1 for savings calculator, press 2 for purchase calculator, press 3 to close program. So if we type in the savings calculator, you probably remember, we put in an income, let's say, I don't know, 500, expenses are, I don't know, 250, and we say 9 months. And what it's going to say is it's going to, do this until it reaches a certain value. So the second program is this purchase calculator. I think Chris used this example of a guitar. So if we had a £2,000 guitar and we saved, I don't know, £125 a month, it would say it will take you 16 months to buy this product, and you will have what's that, £2,000 in your savings account. But what we did was we had like two separate calculators, and then we continuously asked, press 1 for the savings calculator, press 2 for the purchase calculator, and then finally, if you press 3, it will close the program for you. And yeah.
So to remind ourselves, so again, this is going back to loops. We had two types of loops in here. We had the for loops, the for I in range, and the while loops. So the for loops will work for a set number of times. It's saying this loop will run for a number of times. The while loops will run while a condition is met or is not met. So a while loop will just continue going until something happens that makes it stop. Now, in there, we had two things that were both working on months. But on two occasions, we had loops that were doing monthly calculations. So I wonder if there's something there that we can abstract into a function. So let's have a look at the first one. So the first, our first calculator does a number of months, savings, expenses, and what does the second one do? Now we've got while loop, so that's slightly different. Okay, so let's go to the first one and let's have a look at the. So we decided that there's just two slightly different processes they're going through, but we can absolutely that in range number of months. We could absolutely convert that into quite a nice little function.
Yeah, I'm not sure. I suppose let's make a function. I'm not sure what the best name is for this. What do you think?
Expenses. No, it's savings iterator, should we say?
Savings iterator. Okay. And let's think about what's going into this, right? So it's probably going to be the number of months. So we're wanting to, in our savings iterate, pass a number of months, and it will just do that for us. So if we have number of months here,
and income and expenses.
Yes, of course. For me. Yeah, there we go. So all of these things, we can look at this loop, and basically the process we're doing here is we're looking at all what variables there are. So there's number of months, there's savings, but savings, we could put this in a function, and that kind of leads us on to the topic of scope, which is another interesting thing. But there's also income and expenses. So what we can do basically is copy this, what's going on here, and put it in our function, right? So it's going to complain. This is the thing: is if I copy this in, it's going to give us a red line, and it says local variable savings defined in enclosing scope on line blah blah blah. What this means is it doesn't know what savings is. So if we put savings here, it's quiet basically. And then finally,
so what it's saying is, if you remember from the loops episode, if we put a variable inside the loop or outside of the loop, it changed what that meant basically, and we refer to that as scope. And actually, I think we probably need to do at least a part of maybe next week's episode where we look at scope in a little bit more detail, because scope is I wouldn't say a fun topic, but it's a topic that we need to be aware of.
Yeah, scope is one of these things where it trips up new programmers, and it tripped me up. I talked earlier about return confusing the hell out of me. Scope is another one. I was like, the reason I couldn't get my head around scope, and maybe you can relate to this as well, Chris, is I just thought, why do we need scope? Why can't we just make everything global? But I know the reason now. It's one reason is efficiency. We can't allocate memory for every variable and so forth. But definitely,
you shouldn't.
yeah.
But we'll talk about that in more detail as well.
Yeah. But yeah. So let's look at this function. So we have a local variable savings here, and again we'll talk about what scope is and stuff. And
instead of that print, we'll obviously want to do a return.
Yes, so at the end of all this, just return savings. So we can comment this out, I guess. So what this is doing now is we've got savings equals 0. It's going to loop for the number of months you give it. So say you give 5 months, it's going to go for 5 months. And it's going to add onto savings, which is 0 initially, the income minus the expenses. And this is exactly what we were doing here. But now we can reduce all this to basically just asking them for stuff and then going off and doing that. And that's usually quite a good pattern, right? If we look at our savings iterator, this is the cool thing about replay, is it tells you the first parameter is income. So we can just put in income. expenses is, well, expenses, and number of months is number of months. And it might be confusing that these are named the same thing, but basically when they type in income, it's going to go replace this one. So say they put in, I don't know, say they put in 500, it's going to replace this one here, right? And therefore this one. But yeah, I suppose let's run this now, right? So we've took the kind of meat of this calculator here and just converted it into a little function, which is this one here. So if we run this, we'll see, and we use the savings calculator. We put in an income of 500, expenses 250, number of months 12. Actually, it's not going to give us anything back because
we're not printing it.
Yeah. Now this is kind of my fault. I here we're returning the savings, right? But we're not actually doing anything with it. So we can put savings, total savings equals all of this, and then print out your savings after, and put in number of months. So number of months plus months is, and then you can put in str savings. So this is the result. So all this is saying is it's going to say your savings after this many months is going to be this thing, the result from this function. So if we run that and we put in 1, we put in 500, 250, and 12. Say your savings after 12 months is 3,000.
Now, this isn't the best way to do this, but I want to explain that you can call a function from within a function as well. So let's actually put all of that into a function called savings calculator.
Yep.
And savings calculator, again, savings calculator is one of those functions that doesn't really return anything, but it does a job. And in this case, it's actually just tidying up our code a little bit.
Yeah.
This, I must stress, this isn't actually the best way to do this. Or at least it's not the way I would do this. I doubt you would either, Ben. But
no,
But what I just want you to see that actually what we can have in our code is, and sometimes actually, I tell you, sometimes I do this kind of thing just for readability. If we go down to the program, so all we're going to do is if which calculator is equal to 1, run the savings calculator. And that function is kind of self-contained.
Yeah, and this is much more readable to us, right? We can just say if the first calculator is this, run savings calculator, and it's going to go off and do this code, and it's basically just organizing our code a bit better. But as Chris
we
said,
would comment that and stuff like that as well.
Yeah, exactly. We'd add comments and add stuff here. As Chris says, though, it's calling a function here, but this itself is a function. So we're calling a function within a function. And that's possible to do.
Sometimes I think of this as like, do you remember those old choose your own adventure books?
Yeah.
And you're kind of bouncing backwards and forwards between the pages. If you go in this scary cave, go to page 2, and that's kind of what we're telling the code to do. We're saying, right, you've got here, now run the code in this bit.
Yeah. So in this case, we're saying, okay, if they've typed in 1, go off and run savings calculator, and it goes, oh, okay, cool. It goes up to this line and starts going, right, what's your income, what's your expenses, number of months, and then when it comes to here, it'll go, oh, total savings, I need to calculate this, and then it goes off to this one and starts running lines of this line of code here and stuff, and then when this is finished, it goes back to here, and then finally prints this out, and then when this one's done, it goes all the way back to here where it was. So it's like as Chris said, it's like going back and forth. We're going here, and this is saying go off to this function, and then when this one's finished, it says go back here. And
the real joy of this is actually we can start treating our code as blocks, as units. If there's something that we want to improve, or if there's some functionality we want to add, we don't necessarily have to go hunting through the code for the right point. We know all right, okay, we want to tweak the savings calculator, so we just go to the savings calculator function.
Yeah.
And that can make things, when you start, we haven't really written this program to be modular. And one of the examples I gave, and I genuinely, this wasn't pre-planned, I just couldn't remember. I couldn't remember how we'd written the two independent functions. Now, we have two functions here. So we have two calculators that are both doing monthly cost. This is where software design is so important, deciding how you want your code to look before you start. Maybe actually we should do an episode on software design. I don't know.
Yeah.
But we've got two things that are both doing a monthly calculation. So again, when we're talking about reusing functions, what we should have written this in a way is that we can use that monthly calculator to do that for us, and to so instead of having to do two different calculators, we're passing slightly different parameters into the same function that's still going to do that monthly iteration, but in a slightly different way. So we could have, this is quite reliant on a while loop, but we could have written the other one that it worked with while loop as well.
Yeah, exactly. And like you said, I mean, this is where software design comes into it, because I think what separates bad programs from good programmers is just the way you approach a problem, I suppose. I mean, it's all fine to know what a while loop is, and an if and an else if, and in this case a for loop up here and so forth, but putting those things together is quite tricky, and coming up with a really elegant way of doing it's just one of these things where you can there's so many ways of doing this thing, there's so
especially
many...
in Python, which has some neat solutions built into the system.
Yeah, so there's a ton of different ways of doing this, but like coming up with a solution which is the most readable, the most clean, and also quite efficient is quite a hard challenge, and that's where software design comes into it. Should we separate this out into one function? Should we separate it out into two functions? How deep do we go? But if you start putting things too much, like if you put too many functions, if you split this out into absolutely...
You might as well have just written it as a pile of code.
Yeah,
I mean,
exactly.
there are things that there are single lines of code that I put in functions. So one of the classic examples is what we call it's kind of a piece of code that does a bit of sorting, or something that in my line of research I do quite a lot of matrix calculations, or vector calculations. In fact, vector is a really good example actually, because I do all my stuff is vector upon vector upon vector, because I'm calculating steering behaviors of characters in video games. Now, I have single line functions that just do that vector calculation, partly because it is a lot neater to just have a function called calculate forward vector brackets, rather than the line of code that's 100 characters long, and every time you see it I'll go, what does that code do? Oh right, it's calculating the forward vector.
Yeah.
I've called it calculate forward vector, so I know what it is. So that function, just by creating that function, has made my life a little bit easier. I don't have to type out that massive length of code each time, and it's readable. I understand the word calculate forward vector. I don't necessarily look at the math and go, oh, clearly that's what that is doing. And by the way, if you know vector math, it looks nonsensical. At least it does to me with my dyscalculia, right? So that we use function all the time to tidy up our code, but also to make it abstracted. Now, again, if we go up to this, let's look at the function we created, this monthly savings calculator. Now, this does savings, but we could also, again, if we're creating this as a piece of financial planning software, we could have another calculator that's called product profit. And we could do something that says, right, well, product profit is number of sales over month minus marketing expense. Okay, or production expense. And again, we could use the same calculator to do that job. Exactly the same. And that's where the abstraction comes in really useful. And where functions really have power, and again, it comes back to this software design kind of question, is if you can write something that you can apply to various things. And let me go back to my hammer example. One of my, if anybody knows me quite well, I do a lot of woodwork. I do a lot of building. One of my mentors once held up a hammer, held up a screwdriver and said, "Chris, what is this?" I said, "That's a screwdriver." He said, "No, this is a screw turner." He picked up a hammer and said, "This is a screwdriver." Right now, that hammer, for anybody who does woodwork, sometimes you will start a screw off by just tapping it into the wood with a hammer. Now I've got that hammer, I can use it for lots of different things. Anything that I need to hit something, right? If I want to break some glass, use my hammer. If I want to tap a screw into a hole, use my hammer. If I want to build IKEA furniture and slot A isn't perfectly fitting into dowel B, I've been building IKEA furniture today, so don't get me started. I can use my hammer because I'm basically doing the same thing each time. I'm hitting something with force. And that's how we're trying to design our functions. We're trying to design them so that they're reusable. Because if something is only ever used once, from a code efficiency, from a programming efficiency, you might as well just write it as a big procedural list. It's probably less readable, it's less abstracted, it's less it's harder to transfer things, but we want to write those functions in a way that they can be done lots. And again, me and Ben develop video games together, and we do this quite a lot. And actually, one of the things that we often first do is we'll say these are the things that we need, and we'll write a set of functions that we can consistently use to do that.
Yeah, I think that's one of the hardest things about so we've introduced functions, and you can probably see the utility of them and stuff, but going from that and coming up, figuring out the most modular way of doing stuff is really hard. But this is the idea. When it comes to software, essentially you're breaking the problem down into separate little problems within themselves, and making functions is almost like you want to get a function and create a function that is as modular as possible, that can solve as many issues as possible, right? But coming up with that design is in itself quite a hard skill, and it just comes with practice, I think, really.
And I'll finish on this with just one last analogy, and I think we'll end the episode for that. So thank you to everyone for watching. Like I say, I will remind you that we've got the old website that's got all the worksheets. It's got the older episodes. This episode will go up there tomorrow. I once taught an intro to programming class to I think it was set of 10-year-olds. They were programming in Scratch. If you think about your day, there's certain tasks that you repeat multiple times. For example, putting on your shoes. Okay, so you get up and you get ready to go to work, you put on your shoes and you go to work. And maybe, you work in a particularly liberal environment and there's lots of sitting on carpets, and you take off your shoes when you get there. And then when you're about to go home, you put your shoes back on again. That is a function you are performing. There are certain functions that you can say this is a specific activity. We sometimes call them tasks. Right, and that's how you really need to start thinking about your software. What are the specific tasks this software is going to do? And there's kind of a philosophy behind programming. Sometimes we call it function first, where we'll actually start thinking about what those individual tasks are as we're designing our software. Over this kind of more procedure first, this more process. But anyway. These have been functions. So next week, what are we going to talk about next week? Are you even planning for next week? Let me just consult the document.
The document. I think. I'm
sure there's a plan.
Oh, I've yeah.
Yes, so we're going into data lists and structures.
Mm.
We had to start off this brilliant plan, fantastic plan, and we're actually now 5 episodes ahead of where we should be. So because we've been cruising ahead and it's been good fun. So yeah, data lists and structures, and then at that point, I think we might actually start looking at doing some data analysis.
Yeah, I think if you've been watching this series from each week and you're really into data analysis and you're looking at your watch each week, like, God, when you're getting onto data analysis, the idea of this is that we each week we're focusing on separate things. Like today we looked at functions, a few weeks ago we looked at selection, and with these tools, each week we're giving you a new tool to put in your arsenal as a programmer, right? When we've finished with data lists and structures, then we can start looking at, okay, we know what all these tools are. Let's look at how we can actually use the tools that you know about to start doing some data analysis. So don't worry too much about that.
We'll get there. We'll get there. But yeah, no, next week, data lists and structures, so we can actually start talking about at least getting that data and thinking about something useful to do with it. Thank you for watching the Ben and Chris show. I'm Chris, he's Ben, and hopefully we'll see you next week every Thursday at 6 p.m. on the School of Computer Science University link in YouTube, or by all means, looking at the link down below, check out our website and follow through the course on there. Cheers.